Hello everyone, back tuning in to today's first video. Later on today we're going to have a look at the weather for the coming week to 10 days, see what the models are showing. But today's first video on this Sunday morning is going to be something a bit different. We don't often talk about this at Gaz Weather. It's done a couple of updates about this over the past few years. Did one I think in 2013 and one in 2014, but it's not a regular thing by any means. I don't do one a year, if that. We're going to talk about the AMO today, the Atlantic Multi-Decadal Oscillation. There's been a lot of chatter about what's going on in the Atlantic in terms of the colder than average sea surface temperatures in the North Atlantic, and whether anything significant is going on. My point of view, as all the way along, being that nothing all that significant is taking place. It's interesting in its own right, but we're getting this cold anomaly in the North Atlantic. We've had it for quite a while, but I don't think it's anything too serious, anything to be too alarmed about. We're going to talk about the warming and cooling cycles of the Atlantic that occur on a roughly 25 to 30 year average. You get a warm phase, and then you get a cold phase, and it's not a linear situation. So when you're in the warm phase of the AMO, we are, for example, in the warm phase of the AMO at the moment. When you're in the warm phase, not every single year will be warmer than average. Some years you'll get deviations occurring. I think we're having one of those deviations at the moment, have been the past couple of years. But I think we've still got some way to run, actually, with the warm AMO. And I've got a feeling we'll have a bit of a warm-up in the North Atlantic over the next 5-10 years or so, and then we will definitively go into the cold AMO sometime through the 2020s, probably the mid and latter part of the next decade. But I'll show you what I'm talking about in a second. It's a little bit hard to get your head around just talking like this, so it'll be helpful when I've got the charts to show you as well. But before I get on with that, just to say about the ads at Gaz Web, there's links to articles on all of the pages. Have a browse through the widgets and click through the links if there's any articles that you're interested in. Thanks very much for doing that. There's video ads on most of the pages, so you open out within the content, we watch them, it grows back up again. And this helps to pay for GazWebViz.com. Excuse me. I couldn't have the website without the ads and without you engaging with the ads. So by you clicking through the links and watching the videos and just generally engaging with the advertising at the website, it allows us to stay completely free. We don't have to worry about subscriptions. We don't have to worry about pay-per-view, anything like that. We can give you all of our video and written forecasts and Terry's updates as well by the fact that you are engaging with the ads. So thanks so much for doing that from all of us here at Gaz Weather. Right, going to start off with the sea surface temperature anomaly map. The latest one from NOAA was generated on the 7th of April, and of course it's the Atlantic that we're interested in with this. So we're over here. This is the Atlantic Ocean, of course. This is the get rid of that, and this is the tropical Atlantic down here. This is the sort of central part of the Atlantic just here, and then up here we've got the Northern Atlantic. And over the past couple of years, it's really starting in 2014. I'll show you when it started. We've had this cold anomaly here in this northern part of the Atlantic Ocean, and particularly in the northeast of the Atlantic Ocean, actually close to the UK. Now, there have been a lot of chatter, as I say, on the forums and on social media sites and in blogs. There's been quite a lot of chatter, because it's gone on for quite a long while, about what this cold anomaly means. But let's just see when this all started. It's really back in 2014 that this began. So this is from the summer of 2014. This map. This is the 24th of July 2014. By the way, you can find the link to these maps at NOAA on the links page. So you see that back in 2014, in the summer of 2014, generally we had above average sea surface temperature anomalies across much of the Northern Atlantic. Just a little colder blob there through that central part, but nothing really out of the ordinary. Generally, we were still in the warm Atlantic phase at that point through the middle part of 2014. However, as you go through to the next chart, this takes us to the end of 2014, so we're into December. You see that that cold blob that we looked quite insignificant back in the summer has expanded a lot, and now it's covering much of the northern and northeastern corner of the North Atlantic. Still generally warmer than average through the tropics, so and going up towards that eastern and central part of the Atlantic Ocean, the eastern seaboard of the United States. So the northwest of the Atlantic and down into the tropics generally warmer than average, but colder over in the east and the northeast of the Atlantic. Excuse me. This takes us through to April 2015, so gone on to last year. And you see what's happened now is that the tropics have cooled down a little bit, and it's still generally a bit cooler than average in the northern part of the Atlantic Ocean. In between, generally, it's a bit warmer through this central phase. And then we go through to last summer, and this is when things really took off with the speculation, because we had a very dramatic cooling taking place through much of the northern Atlantic. Through the course of last summer, we had this cold blob, as it was called at that time. But notice, even with that, generally the tropical and central part of the Atlantic still quite warm. So you wouldn't say that the Atlantic has shifted into its cold phase by any means. While we have got this fairly impressive cold blob in the north, we've got a fairly impressive warm anomaly to the south and through much of the tropical part of the Atlantic Ocean. And then we go through to the latest chart, so this takes us back to where we are right now. This is April 2016. And again, you see that a lot of cold up in the northern and eastern corner of the North Atlantic, but it's not widespread through the whole of the Atlantic Ocean by any means. So much of the central and tropical part of the Atlantic Ocean just has temperatures around or even above average. All the time over the past couple of years, this cold blob has been generally penned in across this northeastern part of the Atlantic Ocean. I don't want to downplay this. It is a significant factor in our weather. Particularly last summer, I think we can say with fairly good confidence that last summer, the cool temperatures that we had, and particularly a very cool September that we had last year, I think a lot of that probably is down to the effect of these cold and average sea surface temperature anomalies in the Atlantic, because it's a very westerly summer, so winds were constantly coming in from the west, running over this cold blob. And for sure, it did lower the temperatures and probably give us quite a coolish summer last year. And you have the same pattern setting up this year if this cold anomaly continues, and I assume it will do, although it may moderate through this year. I assume it will still be influencing the Atlantic to our west through the course of this summer. If we have it in the summer, I assume it will lower the temperatures again this summer if it's another westerly summer. So I don't want to downplay the idea that this is something significant, but I don't think this is a fundamental shift into the cold phase of the Atlantic multi-decadal oscillation. So this is showing the monthly values for the AMO index going from 1856 to 2013. I have no idea how they calculate this going back into the 1800s, but you can see very clearly that what we're talking about here is warming and cooling on a cyclical basis of the Atlantic Ocean. So if we go back to this period just here, which is 1860, going through roughly to around 1900, this is a warm phase of the AMO. Now, for sure, we have got colder interludes coming through. Remember, this is back in the 1800s, in the Victorian era, when it's generally a very cold time. Anyway, we're still coming out of the little ice age, so you'd expect the Atlantic to be quite cold. And even in this warm phase of the AMO that occurs from, let's say, 1860 here to 1900 just here, we are getting deviation. So it's not completely warm. We get these drops in the sea surface temperatures in the Atlantic Ocean going colder at times. But overall, this is the warm period of the AMO at the end of the 1800s and to around 1900. Now, from 1900 to around 1935, which is just here, excuse me again, got a little bit of a frog in my throat tonight, we're in a cooler phase. I should say tonight when I'm recording video, of course you're probably watching this on Sunday morning, but anyway, from around 1900 to 1935, we're in the cool phase of the AMO. And although we do get a bit of a spike up here around I think that's probably around 1916, something like that. Generally, most of the years in this period are coming through quite cold. We then go from 1935 to around 1940, I think it's around 1963 actually, just here. And this is quite clearly again going into another warm phase of the AMO. Significantly warmer than average sea surface temperatures being recorded in the North Atlantic through this period. Again, not completely warmer than average by any means, because we have these colder years coming through. They're in the minority, but they are there. We do get some years that deviate through this. And then the last cold phase of the AMO really occurs, let's say, from around 1963 going through to 1995. So just here, this is the last cold phase of the AMO that we went through, covering particularly the second part of the 1960s, into 1970s, 1980s, and then again going into the early part of the 1990s. As you see, once again, it's not completely cold. We do get some years that deviate. This is one year just here in the 1960s. This is in the 1980s, where we deviated a little bit as well. And particularly as we go through into the 1990s, we start to pick up the warmer phase of the AMO. And then we definitively shift into that warm phase from around here and going through to 2013. So this takes us from around 1995 to 2013, when we're back in the warm phase of the AMO once again. And you notice that what happens here, this part is quite interesting just here. Before we go into the warm phase of the AMO, and we're still in the cold phase generally, we do get a few years that start to trend upwards. And they're just here, start to warm a little bit, albeit not definitively going into the warm phase of the AMO, but just a few years that begin to maybe tell you where the Atlantic is going to be trending in the cyclical time scale. So it's still within the cold phase of the AMO for sure, just here, but we have got a few years beginning to come through towards the end of the cold AMO that start to become warmer before it definitively shifts into warm phase of the AMO just here. And of course it's the same as we go through into the cold phase of the AMO. So just here, for example, back at the end of the 1800s, we do get quite a few cold years. Then there's a final warming that occurs just here before we definitively drop down into the cold AMO once again. And the next warming also just here, we get a warming that occurs still within the cold phase of the AMO before there's a drop, and then a definitive warm-up that occurs around the start of the 1940s. So the idea is that we've got the warming and cooling phase of the Atlantic, of course, and years within these warmer and cooler cycles that are deviating. But as you get towards the end of the cycle, whether it's a warm cycle or a cold cycle, and you begin to shift on to the next cycle, you'll start to just maybe get a few hints coming through that the Atlantic is getting ready to change. And I've got a feeling that's what's going on right now with this cold blob that we've been seeing over the past couple of years. Because if you look at this, the last warm phase of the AMO that occurred, as say, from 1935 to around 1962, and then you look at this one that occurred in the 1800s to 1900, you see that this is much shorter than the other two warm cycles. So if we was definitively shifting into the cold AMO now, this would be a very, very warm, this would be a very, very short cycle, I should say, just here. And I think it's too soon for us to be shifting into that cold AMO at the moment. But I've got a feeling what's happening is that not only have we had a deviation, we know that deviations do occur when we're in the warm phase of the AMO. We will get years that trend colder. Not only have we had a deviation, we probably had a fairly significant deviation. That's just telling us that the Atlantic, whilst it's not going to shift into the cold AMO imminently, it probably is starting to get itself ready to shift into that colder phase of the AMO. Now, this is quite an interesting chart. I found this at the website rms.com. This is risk management, a risk management website. I think it's from America, and I've got the link to this website on the links page. So again, this is monthly AMO index values from 1860 to present, but this was a little bit more up to date, I think, than the chart we was just looking at. And it's just over here that we're interested in. So again, we know we've got this warming, cooling going on over the past sort of 150 or so years, and we've got the final warming that's occurred just here, of course, is 1995, as I was saying. It's just here that we're interested in. This is the colder period that we've had over the past couple of years. So you see, even though it has been colder in the past couple of years in terms of the Atlantic, it's nothing to be unduly alarmed about. Look how much colder it was through the through the last phase of the AMO just here, from the mid-1960s to the mid-1990s, and again from the previous cold phase of the AMO, which was just here, going back into the first sort of 35 years of the 20th century. Much colder in terms of those sea surface temperature anomalies than we've had in the past couple of years. And again, even then, it's not been every single month over the past couple of years that's been posting colder returns of the AMO, because even then there's plenty of red going on up here. So I don't want to downplay what's happened, but I don't think it's a definitive sort of shift into the cold AMO. This chart is showing you the numbers on a month-by-month basis going back to 1948 in terms of the AMO index. So, for example, 1948, actually quite a cold year, with many of the numbers coming out negative in terms of the Atlantic multi-decadal oscillation through the course of that year. The last cold phase of the AMO, which I said runs from around 1963, it's from around here, this year just here, 1963, going down to around the mid-1990s just here. And notice that in the Januaries of those years, pretty much every single January has a negative number. I can't draw a straight line, but pretty much every single January from 1963 down to 1995 comes out with a negative, a minus number in terms of the sea surface temperature anomalies in the North Atlantic. This is from NOAA again, by the way. So we come down to the present situation, and we come to 2014, which we know in 2014 we did go a bit colder, and there are negative numbers showing up, so there's several of them through the first half of 2014, and then they ease back a little bit as we go into the second half of 2014, and then 2015 posts some negative numbers as well. But it's not a definitive drop into negativity. That's the point that I am trying to get across. And if you want to see what a cold Atlantic really looks like, this is from NOAA. This is sea surface temperature only from November 1984. Look how much colder the Atlantic was then compared to the situation now. All of the North Atlantic is cold. All of the tropical Atlantic is cold. Just this little bit of the Atlantic, very small part of the Atlantic in the central area is a little bit warmer. But generally from Greenland up here down to the equator down here, it's more or less colder than average through this part of the Atlantic, through this part of the Atlantic Ocean up in the northern and central and tropical part of the Atlantic. That's what it looks like when you're properly into a cold Atlantic multi-decadal oscillation. If you want to have a look at what a warm Atlantic multi-decadal oscillation looks like, by the way, this is from 2005. This is indicative of what we've been seeing over the past 20 years or so since we shifted into the warm AMO in 1995. This is how a warm Atlantic looks in a warm AMO. And as I say, this is from 2005. Notice how much warmth there is both around Greenland and through the tropical Atlantic. Again, we see it in 2010. I think 2010 is probably the peak of this warm AMO. I'll be surprised if we get back to the sort of temperatures that we had in 2005 and 2010. And again, this is how this is how the peak of the warm AMO looks, with just incredible warmth really across virtually the whole of the North Atlantic. So when you're peaking in the warm AMO, it is as warm as the peak of the cold AMO is cold, if you see what I mean. So that's the cold AMO. I think this is around the peak of the last cold Atlantic multi-decadal oscillation. I say this is from November 1984. The peak of the warm AMO is about as extreme as the peak of the cold AMO. But if we come back, finally, to the current situation, well, for sure, we have got this cold blob in the North Atlantic, particularly on our side of the Atlantic. But you notice much of the tropics is still generally quite warm. Much of the central part of the Atlantic is still generally quite warm. And over towards the eastern seaboard of America, in the northwestern quarter of the Atlantic Ocean, it's also quite warm there as well. Now, what I think is going to happen over the next couple of years, in the next 2-3 years, I think we'll see this warmth, this cold area, I should say, that we've had in the northeastern Pacific. I think we'll see it shrinking, easing away, and I've got a feeling the next sort of 3 to 5 years we'll see the Atlantic generally warming up again, albeit I don't think we'll get back to where we was in 2005 and again 2010. I think 2010 was the peak, and I don't think we'll get back to that. But I've got a suspicion that over the second part of this decade will probably warm things up again, and then we may drop in definitively in the 2020s into the proper cold Atlantic multi-decadal oscillation. When that happens, we will find that the summers generally become a bit colder. So what we had last year in 2015, I think that's a sign of what's to come. We'll probably lose the warm summers that we've had over the past sort of 25 years, albeit a lot of them have been very wet as well. So we lose the energy a little bit out of the atmosphere, so not as warm, but probably not as wet with the summers as we get into the cold AMO. And in terms of what happens in winter, well, it has very little effect really on the winter. We'll still get most of the winters coming through milder than average, because if you think that in summer we're talking about westerly winds coming across a cool Atlantic Ocean, and it's a bit cooler than average, so that's why it drags the temperature down in summer. But in winter, even if the sea surface temperatures are 2 or 3 degrees colder than average, if it's westerly, it's still going to be significantly milder in winter, even with a cold Atlantic, than it would be if you've got northerly or easterly winds coming out of the Arctic or coming out of Siberia. So that's why the effect of the cold AMO is less so in the winter compared to the summer. But nevertheless, it is important that we monitor these phases of the warm and the cold AMO, and we will still get, even in the cold AMO, we will still get mainly mild winters, but occasionally we'll still get a colder winter coming through. So it makes very little change, makes very little difference, I think, for the winter, but for the summer, it does mean that when you're in a cold AMO, you generally trend towards cooler summers, but you lose the energy, so probably not as wet. But the overall idea that I want to get across for this update is that I don't think this cold anomaly that we've seen in the Atlantic, it's interesting how it's persisted for so long within the warm phase of the AMO. Quite unusual, but it's done that. But I don't think it's anything to be too alarmed about. I don't think we've finished with the warm AMO yet, so I've got a feeling we will warm up the Atlantic actually over the next sort of 5 years, and then we go definitively into the cold AMO in the 2020s. Hope you found the video interesting. It's very different to what I usually do at Gazovin, so we'll be back to normal in a little while because I'll have a look at the models, see what they're showing for the coming week or so. So come back to that later on today. But that's all for now. Thanks for watching.